Hello, Accelerated Math 6-7 students. This is Module 8, Lesson 8, and this lesson is called Comparing Tape Diagram Solutions to Algebraic Solutions. And our goal for today is we will learn how to use tape diagrams to solve equations. The question that I want you to be thinking about during this lesson is, how can the tape diagram help you understand how to solve the equation? All right, so things to remember. First of all, we have some vocabulary words that you really need to make sure that you are paying attention to. An expression is a math sentence built of numbers and symbols, and there is no equal sign. So an example of this would be 1/2 times the quantity x plus 8. That's one example of an expression. The other example of an expression is 25 minus x. And we know those are expressions because there's no equal sign. And we also know that those are expressions because they are representing a numerical amount. Okay? An equation is a math sentence built of numbers and symbols and an equal sign. So the equal sign is present when you're working with equations. So the way that we changed the expression from above into an equation is we added an equal sign and a value. So this one says 1/2 times the quantity x plus 8 equals 28. And when you have an equal sign, you can solve it. When you don't have an equal sign, you can't solve it because you don't know what it's equal to. So it's very important. The only way, if somebody tells you that you have to solve an equation, like our goal says we're going to solve equations, we can't solve if it's just an expression. You can simplify it and make it smaller, but you can't solve it. These you can solve because it has an equals amount. 25 minus x equals 15, okay? And so it's very important to know that you can't solve expressions. You can simplify expressions, but you can't solve them. The only thing that you can solve is an equation because it tells you what it's supposed to equal. All right, so our goal is today we will learn how to use tape diagrams to solve equations. So we're going to actually try one, and here's a tape diagram. Remember, a tape diagram is a model used to see how to solve the equation. And so it's a visual representation that really, really helps us. And so I'm going to teach you how to do this with using the distributive property, because what you see on this paper right here, all of you should be recognizing this. This is what you see when you're working with the distributive property. So what this example says is that we have x plus 2 5 times. The way we read this problem is we say 5 times the quantity x plus 2 equals 40. And so what we have to remember about this is it's saying that we have x plus 2 and it's happening 5 times. And since we're using tape diagrams, here is how we would do it. First thing that you have to do is you have to draw a tape that represents what's inside the parentheses. So if I'm going to draw a tape, here's my tape, okay? And I know that I could draw it like this, where I could say that this represents the x and this represents the 2. And since we're adding them, this tape diagram shows us exactly what we're supposed to do because you're taking the amount in here plus the amount in here to give you an answer. But this by itself does not equal 40. If we do it 5 times, then it equals 40. So that means I have to draw 5 exact tapes because the tape is what is inside the parentheses, and outside the parentheses tells you how many tapes you have to have. So according to this equation, I have x plus 2 plus x plus 2 plus x plus 2 plus x plus 2. And the reason why I have that is because this number right here tells you how many times you have to draw your tapes. Okay, so inside goes inside the tape. Number on the outside tells you how many tapes you need, and then what you have to remember is that all of this equals 40. Okay, and so now you just count what you have. So I have 1, 2, 3, 4, 5. I have 5 x's plus 2, 4, 6, 8, 10. I have 10 as the value, and all of that equals 40. So now all of you should be able to go, okay, what number times 5 and then I add 10 to it, gives me 40. Okay, well, if I know that I have to add 10 to get to 40, then I know that this must equal 30, because 30 plus 10 equals 40. Do you all see it? 30 plus 10 equals 40. So what number times 5 makes 30? So I know that this right here has to equal 30, because 30 plus 10 equals 40. Well, what number times 5 gives me 30? I know that the number has to be 6. Okay, so now the way you check it is if we put 6's in here, 6, 6, 6, 6, 6, we know that 6 plus 2 is 8, so each one of these tapes is 8. 8 plus 8 plus 8 plus 8 plus 8 is 40, because 8 plus 8 is 16. 16 plus 8 is 24. 24 plus 8 is 32, and 32 plus 8 equals 40, so it worked. Okay? So that is how you use tape diagrams to help you solve equations. So remember, the innards inside the parentheses is what you build your tape into. The number on the outside tells you how many tapes you need, and then all of them equal 40 because this is an equation. And so then your job is to figure out what the x would be to make it true. Okay? And that's pretty much how you use tape diagrams to solve equations. It's very, very simple. And actually, I love it because when you get these really tricky problems, knowing the fact that you can use a tape to show it is very helpful. All right, kiddos, let's go back up to our goal really quick. Today we will learn how to use tape diagrams to solve equations, which we just did. How can a tape diagram help you to understand how to solve the equation? The way it does is it allows you to see what's happening, so that's how it helps you. All right, kiddos, that's all I have for you today. Bye.